My background is in testing, and that is something that we're going to talk about today. This is not going to be the sort of the let's test all the things in TDD is good kind of talk. What we're going to do instead is try to get on the same page, try to talk more about testability, talk about stubbing versus fakes and versus mocking and what that means. We're going to talk about factories over fixtures, and if we have any Ruby engineers in the room, please don't boo me for saying that. You're probably used to using factories. I am going to mention some personal preferences just because this is my talk, and we're going to try and make testing a bit more fun and save the world while we're at it, so just an easy mission. So hopefully at the end of the talk, you're going to feel a bit less grumpy about testing and a bit more happy and like badass and ready to like write some tests. So let's start. Testing, why are you so weird? Turns out testing is not an easy problem to solve, and the reason why most people feel so awkward about testing is usually because less about the fact that the unit test is so hard to do and more about the fact that the code is poorly designed. Ideally, whenever you want to write some tests, you don't want to think too hard. You've already solved your problem, you already have some code that works, you don't want to jump through even more hoops to be able to test. So you want something that's readable, easy, reliable, and fast. You want clear code, no hidden tricks. Even if it's rocket science, you should be able to describe it in simple words somehow and not over-engineer it. You don't want any flakiness because you need to be able to deploy to production quite fast. And you don't want to wait forever either, so let's say something burns in production, we've probably seen it before, all of us. I don't want to wait for half an hour for my tests to run in dev to make sure that the fix is right and then deploy to production. And I want it to be easy to write the tests. So we're going to step aside from, which framework to use and talk more about what we can do to make this experience more enjoyable for all of us. So keep it simple and start simple are some very, very good rules in anything. And starting with unpoisoning the code base. So turns out it's actually not that hard to do, and it should be something that, it's kind of intuitive. But for some reason, as the code grows, you end up having like this monolithic app that does a lot of things and then has a lot of tests that are sometimes unit tests, sometimes system tests, etc. But a good rule to follow is a single responsibility principle, and we're going to talk a bit about what that means. And deterministic factors only, so like no use of random or like system calls and how we can make the interaction with that a bit better. Having a clean API and API adapters when a clean API fails. And something that I'm calling lazy-driven design, and I'll explain that a bit further, but don't quote me on that because I think it's a name in progress. It's more like an idea to follow. So single responsibility principle and why that is very good. We all fear random, and we all know that random is something that's very, very hard to test. Time is also something that's very, very hard to test. So let's say we have a function, a method that determines the time of day. It goes and it gets the time from daytime now, and then based on that, it's deciding what part of the day that is. Is it night? Is it afternoon? What is going on? This is very hard to test because the function is kind of lying to ourselves. It's not just returning the time of day, it's actually going somewhere and getting some data, which is online too. So being able to test this is not impossible, but it is hard. You'd have to have some sort of test that changes the system time to 6 a.m. and then goes and gets the time of the day, and then it's asserting that that time of day is morning, and then goes back and reverts the time of day. Not the most pleasant experience. Instead, what we could do is a simple thing and moving the daytime as a parameter, and then my function is only responsible of one thing, which is based on my parameter, I'm going to determine what my output is. It sounds logical, but you'd be surprised what happens in legacy creepy code. So this is a kind of a good rule to follow, and the test looks way, way nicer where I can just have a predefined daytime. I can call my function with that parameter and then assert that the response is correct. So much nicer. Inheritance is also something that is usually kind of tricky, especially when used improperly. Python wants to be object-oriented, so inheritance is highly encouraged. However, there are some cases when you'd be much better off and it would be much better suited to use composition instead of inheritance. And this is like an attempt to give an example about that. So you have an invoice generator that just prints some information and calculates some tax, and then prints your order and saves the invoice. And then you have a billing service that for some some reason right now inherits from the invoice generator. So it's going to create an invoice and do all sorts of things. This is this is difficult to test. It's not impossible, but mainly because it actually inherits from something that it shouldn't. So it will make mocking very, very awkward, and it would make you jump through a lot of hoops to be able to test. A better way of doing it is actually using composition. So at the constructor level in billing service, actually passing a generator, it can be the invoice generator, or it could be something else. So let's say that your billing service expands, and instead of invoices, you have subscriptions, or you have all sort of factory that creates invoices. Now it can be anything, and it's not just responsible to return an invoice. It can do anything you want to do that's related to billing. And then it will go ahead and create the invoice as well. And when we're going to test this function, it's just so much easier to mock the generator and make it do something, and then test that the billing service is correct. Clean APIs are very, very important, and this is kind of like a part one of why this is so important, and part two is going to be for mocking. Realistically, users are only going to care about how they're interacting with your library's API and not the library itself. So say you have like a service that at some point does some encryption. I don't want to know how that encryption is implemented, especially because some of them like have like a pretty big library behind them. So I don't want to go and say, give me this thing, and then give me this thing, and then run that. It will make me think about how that encryption actually works. And while I should be aware of that, ideally I don't need to see all that in the code, mainly for readability purposes, if not for testing, at least for readability purposes. So ideally, like I'm a client, let's take a real world example, and I'm in a coffee shop, which happens very often for me, and I want to place an order, and all I care about is for someone, some magic fairy, to give me back my order, and that's it. I don't care about what the person in the coffee shop will do. I don't care that there's maybe like an order processor somewhere that will validate my order and take my money and validate that my card is valid and has like enough currency in it, etc. I just want my coffee and get out of there. So as like a very good rule to follow is one clean, simple point of entrance that ideally returns one thing. That may or may not be applicable to like one thing always, but at least like try to like downsize the number of calls that you're making to your API. So if we think of this at like abstraction layers for like your actual code, ideally what should happen is that you would have like an interface that interacts with your client, be it some other third-party library or your test, and then the low-level manipulation of data would be like abstracted in like another file or like another module. It kind of depends. You should be able to slice an individual piece of functionality and module at any time and say, hey, this is what my billing service is. It's only responsible for doing billing stuff, and that's it. There's a bunch of reasons for that. One of them, if you work in a startup, you're probably very familiar with this. There's, again, a monolithical code base that keeps growing and growing and growing, and everyone's kind of afraid to split it up to the point where, hey, you need to scale. And then you're thinking about that, hey, maybe I should extract my billing service somewhere else, and maybe I should extract my like user service in another layer, and it would, unless you have like a clean API, you're gonna end up having to add one to be able to slice. So this is kind of a good thing to keep in mind at all time, especially when you're developing a new service, put an API in front of it. So what if I told you that you could be lazy and still have good tests? So again, name, I don't know about the name, but the idea is that you should avoid writing your library until you are done defining how it will be used. And that is not just like client level, but like how it would be used by other libraries as well. So I usually start with a simple test script written in Python, or it can be in anything, Java, Ruby, doesn't really matter. And I write clear expectations of what my code will do. So it's like, hey, give me the bill. No weird implementation quirks. So ideally, like I don't want to describe that in too many steps. I wanted to do one thing. So it will be a summary of just one action. And then it's usually no more than 5 lines of code, and that includes asserting. So like let's try to like minimize the size of tests. And then I go and I write my interface, which again will do a dummy thing for now. And then I can start thinking about internals, but like at a much later stage. It's kind of what TDD is trying to tell you, but I kind of feel like this is a much nicer way for like me to like wrap my brain around it, because it is kind of like a different perspective on things, excuse me, and you are using kind of a different hat when you're testing. So by doing so, that means that your internal code can change. You can do whatever you want with it. And what because you're keeping your API consistent, that means that there's no need for test refactoring. And your tests are still going to ensure that you didn't fuck something up, and it's basically less work, so you're kind of being a bit lazy and have time to drink more coffee or something. Okay, something that is also quite weird in testing area is that everyone uses different terminology. And we are kind of all talking about the same thing, but sometimes the words don't match up. And it's making very hard, like you can notice this around documentation or tutorials or whatever, where it's very, very hard to like figure out what someone actually meant. So this is an attempt to kind of like get on the same page and use the same terminology. So I'm going to use the one used by Gerard Mazaros. I hope I'm pronouncing his name correctly. He wrote a really good book called XUnit Test Patterns Refactoring Test Code. And in that, he talks about test doubles. So what a double is actually everything that is trying to behave as something else. One of those doubles is what we call a fake. So it's never too late for trick or treat. What a fake provides is no validation on the way it is used. However, it's a simplified implementation of a dependency. And it's usually used in a case where you just want some data and that's it. A very good example of that would be using in-memory databases. And that's kind of a talk on its own, so I'm not going to go into that like for very long. But it can also be used whenever you're trying to test like the caching or like this, that the data, getting data from a database or that it made it to a database, etc. And there's, again, no validation in the way that it is used. You can do some crazy stuff with it, for example, faking a Python package. So let's say you want to trick your test into thinking that there's a package there when there's not. So what you can do is just create a class and then create a static method that just does A plus B. And then as part of your system modules, you can actually add that fake module. So it's quite crazy, but it works whenever you want to get rid of some dependencies at test time or some packages that you don't want to include, but you don't want your test to be failing because of that. Stubbing is something that is usually confused a lot with mocking. And stubbing to me is more like give me data. Give me data, I don't care where that data is coming from, I care that I need that data for my test. And I also care sometimes about recording my calls. So for example, if you're testing an email client, you might want to record the calls that you've made to the gateway, etc. And it's just going to provide some predefined answers that you can use in your test. It sounds actually very, very simple. There's different ways of doing that in Python. One of them is using pretend, which is what this example is about. So what I'm doing with currency code, I'm making it always return euros. And the call recorder that I mentioned, in this case, it takes a lambda and it does x by 2. So if I'm calling my function with the argument of 5, it's going to return 10. It's very, very easy. There's also like more advanced implementation of stubs where like you can actually put a stub in front of like an entire class. Again, it's kind of a talk on its own, so I'm just gonna focus on more like clearing the air a little bit around stubs for this talk. Mocking though, mocking is something that is quite often used in tests and very powerful, mainly because it allows validating around how on how your dependency is used by the class. So mock function will return a predefined value, much like the stub. And the mock object will have all the attributes and methods that are defined in an actual object without actually creating a real object. Some sanity checkpoints around mocking, because there's a bit of a debate of like when and what and how they should be used. You should care that your library successfully called the system function to fire your alarm. You shouldn't care about experiencing an alarm every time a test runs. Quite simply, what if we were testing a rocket launch, or what if we were testing that something can be set on fire when it should be set on fire? You should care that with mocking, the slow code is out of your test. So for example, network calls or file systems. And we're talking, it can be like a Unix file system, or it can be like HDFS, it doesn't matter. Everything that interacts with a disk is going to be slow. You shouldn't care about testing the functionality of a third-party library. That's why you mock it. You need to assume that they did a good job testing their library. And if they didn't, there's ways to go around that. But for the purpose of your test, you only want to test your code in isolation. So testing without mocks, let's say we have a function that removes a file name. So again, something that uses system calls and interacts with the file system. In your test case, you'd have to actually jump through a lot of hoops to be able to test this. You need to have a real file, and then you need to like delete the file and check that the file was deleted. And then if you fail to delete the file, then you should probably have a teardown that handles that case accordingly. It's quite a heavy test case to implement, and you have to worry about a lot of things. You have to worry about file permissions, being able to create files, etc. So it is quite painful. There's a lot of things to consider. A much nicer way to do it would be to just mock it. So for example, I have a log rotation service that just does a rename, and then for the test cases for that service, I'm just going to mock the service OS path in OS. I'm just going to tell it to always return that it's a valid file, and when I'm calling rename with any path and any destination, it's going to assert that they got called with the right parameters. And I don't care what rename does, I only care the fact that I called it with the correct information. A very good question here would be, hey, why mock your package.os.path instead of actually mocking OS? The reason for that is that at runtime Python does some really sneaky things, which is your package is going to have its own OS, which means if you're mocking OS, it's going to be different from the OS that's actually used in your module. So you're going to end up with some discrepancies there. And also one of the downfalls of using patch is the fact that if you're looking at how I'm using them, then I'm calling OS path in OS, and then as arguments, you always have to call them reverse. That's a bit of a thing that can trigger some unexpected behavior. So there is a bit of weirdness, and it takes some getting used to, but it's quite a powerful and nice way of testing something that interacts with the file system, for example. Okay, what if you want to mock an object? So say I have a log service that calls my log rotation. There's two ways of doing that. So you can mock out the log rotation service rename method itself, or you can just mock the instance, and we're going to explore both. Mocking the rename itself is quite similar with what we've done so far. We're just going to call the log service and then just mock, using mock patch object, we're just going to mock the rename method. And then we're going to verify that we've called rotate with the right parameters, and that we've also called the rename on the rotation service with the right parameters. Creating mock instances, it will create like a functionally equivalent instance of the provided class, which means like whenever you're calling rename on that mock. And the good thing about that, and what I want to mention, is that it will raise exceptions if it's used in illegal ways. So the fact that you're using mock create auto-spec instead of just using mock, if your log rotation service at any time will change the number of parameters, then that's going to generate an error and make your test fail, which is actually what you want to do. You don't want your test to pass if now it requires more parameters than before. And it's a very important difference between mock and MagicMock and auto-spec, and always favor using an auto-spec instead of mock and MagicMock, mainly because of this thing. To test it, it's actually very easy to test. So let's say I have something that tags a repository, and then I'm writing a test for it, and right now it only takes an argument, which is a name. If at any time I'm adding like a confirmation and I'm saying, hey, if confirm return okay, else return nope, my test will still pass. So to my point, try and use auto-spec instead of mock and MagicMock if possible. Factories over fixtures sometimes. Factories is something that is very popular in Ruby, and it's based on Thoughtbot's factory girl, and in Python it's factory boy. And it will replace static, hard to maintain fixtures with just easy to use factories that just use parameters whenever you want to create complex objects. So your objects are going to be customized for the purpose of your tests. It's going to be like a much nicer and cleaner way to do it without a lot of code and without worrying where your fixtures should go, like is it at module level, is it at package level, what's going on there. And it's particularly useful, especially when you're working with models. So let's see what that looks like. Let's say you have an account, and your account has a username and an email, and then you have a profile for your user. And it's very popular right now to talk about politics, so why not? So you have political views Democrat and political views Republican, and every person gets assigned a profile. If we try to transform that into factories, what you'll have to create is two classes, one for an account and one for a profile. So profile factory, account factory. And then define what your username, email, and all the other information would look like. And then if you look at the political views, one of the very nice benefits of using factories is that you can actually use an iterator and it will return like one or the other. And you can actually define like a profile factory for like a specific value. So for example, in my case, it's Democrat, but it could be anything like student versus teacher or whatever. Where I'm selecting, in my case, it should have been the bug in my code, it should have been political views Democrat, anyway. And assigning the first name and the username is just a sequence of characters. If we want to write a test for this, it will be very, very easy to create as much information as I want. So for example, in get profile stats, I'm creating a batch of 4 people with the profile factory, and then 2 with the Democrat profile, and 2 that are from planet Asgard. And then I'm asserting that I only have 2 people that are from Asgard and 6 from Earth, because Earth is the default. And then asserting that only 1 person is a Democrat. So again, it's just like a much, much nicer way to create a lot of information where you don't where you want to be very opinionated up front about what your object would look like, and then use that in your tests. The same thing, you can use the profile factory to create like a badge. So for example, I want to create 50 people, and I can specify their political views, first name, last name, for each and single one of them, and then I can actually use this make objects into a fixture. If I really, really want to use fixtures, we can use a combination of factories and fixtures, and this is a good example of that. All right, going a little bit into frameworks. So framework, it doesn't really matter what you're using. What matters is defining what your needs are, and then going and choosing your framework should be according to that. So ideally what I'm looking for is like a framework that allows me to do unit tests along with functional tests. And how to choose? Well, a very good way to go at it is setting up your requirements. So I want to be able to have a setup and a teardown. That's very important for me. I want to be able to have multi-level fixtures, so parameters, and being able to pass parameters, and being able to specify that a test is expected to fail, especially if we're trying to write the test before we implement the code. I want to be able to continue through a test function after failure. There's not a very straightforward way of doing that. You'd have to write some code for it, but it is quite possible, and both unit test and PyTest and those support this feature. I want to be able to mark a test as expected to fail, minimum boilerplate code, and easy to parse reporting. And the personal preference, again, just personal preference, would be PyTest, mainly because powerful named fixtures, the failure handling, failure handling and feedback, skipping in a very, very simple way. It turns out in those it's actually not that easy to skip a test. And clean and simple asserting. I'm a huge fan of writing as less code as possible to do what I want to do. So in PyTest, it's just assert my function equals 4 instead of doing assert equals and so on. So again, just a personal preference. So thank you very much. You can find me on Twitter, GitHub. And again, this is kind of like a split. It would be different talks on their own. So I'm going to try and run a workshop really, really soon around this. Possibly with Python Ireland, we'll talk. So I will try and take your questions offline just because I'm usually conscious of everyone's break time. So thank you very much and enjoy the rest of your day.